Good morning, everyone. Video number 2 today.
All right, Honors Math 9. Here's day 2. We're going to start rationalizing the denominator. All right, so we're going to do 2 different types of examples. Just a reminder, so when we have integers written inside of the radical, it's important to always write these numbers in terms of an exponent. So let's say we have the number 75. 75 is the same thing as saying 25 times 3, or it's the same thing as saying 5 squared 3 to the 1. All right, so there's not really any notes. We're just going to go through a couple of examples together. We have, I think, 7 examples to do. So example type 1 is just called rationalizing the denominator. So our first one is example A. If we have 3 over the square root of 5x. Again, remember it's not proper math grammar to leave a square root in the denominator, so we have to get rid of it. So this example, we're taking the square root of 5x. Remember, what we're going to do is multiply the top and the bottom by the square root of something. So what we have to do is think of something to get rid of the square root. So technically we have 1/5 and we have 1x. Since we're taking this square root, how many more 5's do we need to make a group of 2? 1 more. How many more x's do we need to make a group of 2? 1 more. So technically when we multiply the top numerator and denominator by the same thing, we're multiplying it by 1, so we're not changing anything. Now when you multiply fractions, multiply straight across, we have 3 square roots of 5x over the square root of 5x times the square root of 5x is going to be left with just 5x, because technically it's 5 squared x squared, and what's the square root of 5 squared? 5. What's the square root of x squared? Just x. And there we go. Again, that was a simpler example. We are going to get a little bit more complicated. So let's try example part B. If we have this time the square root of 2 over the square root of 3w. Again, the square root of 2 is fine. We can't have the square root of 3 in the denominator. So again, we're taking the square root, so we're going to multiply the top and the bottom by the square root of something. We only have 1 3 and 1 w, but we need a group of 2. So we need 1 more 3 and 1 more w, and whatever you do to the denominator, you have to do to the top. And when you multiply fractions, you multiply straight across. This time, because the 2 is inside the square root, we can multiply it to the 3. So we have the square root of 6w over 3w. And again, you cannot simplify anymore because this 6 is in a square root, this 3 is not. So that's it for example part B. Good. And moving on to C. This time we have 7 over the cubed root of 9y squared. Again, always writing numbers in terms of quantity squared. So I'm going to rewrite this as 7 over the cubed root. Instead of writing 9, I'm going to write a 3 squared. And instead of y squared, is just going to stay exactly the same. So now we have to multiply the top and the bottom, this time by the cubed root, because we started off with the cubed root. How many more 3's do we need in order to make a group of 3? Well, we already have 2 of them, so we need 1 more. How many more y's do we need? 1 more. And now again, multiply straight across. So we have 7 cubed roots of 3y over the cubed root of 3 squared times y is the cubed root of 3 squared, or cubed, which is just 3, and y. And 7 and 3 doesn't simplify anymore, so that right there is your final answer. And our last example for this type is part D. A little bit more simplifying, but the same process. We're doing the cubed root of 4x over the cubed root of 16y to the 5th. Again, I'm first going to rewrite everything, all the numbers in terms of an exponent. So we're taking the cubed root. 4 is the same thing as saying 2 squared x over the cubed root. 16 is the same as 2 times 2 is 4, 8, 16. 2 to the 4th, y to the 5. And again, before we rationalize it, I'm going to clean this up a little bit. If I have 4 groups of 2, how many groups of 3 can I take out? 1. And there are 1, 2 left over. How many groups of 3 can I take out of this group of 5 y's? I can take out 1, and I'm left with 2 left over. The numerator does not simplify because we need groups of 3. We only have a group of 2, and technically a group of 1. All right, so now we're taking this 2y is fine, but this cubed root right here is not. So again, we're going to multiply the numerator and the denominator by the cubed root of something. How many more 2's do we need to make a group of 3? 2 more. How many more y's do we need to make a group of 3? 1 more. So we're going to multiply the top and the bottom by the cubed root of 2 squared y. Again, I told you this one had a little bit more simplifying. The denominator already had the 2y. And then when we take the cubed root of 2y, we're going to have 2 and another y, because this first 2y was already simplified out beforehand. And now in the top, we're going to have the cubed root of 2 to the 4th x, y. Cool. Almost done simplifying. Let's see how I'm doing on space. Okay, good. The denominator is 4y squared. And again, I can take out a group of 2, cubed root of 2xy. 2 over 4 simplifies to 1/2. So you can have that 1 there, or you don't need it. You can see the 1/2 y squared. There we go. We have one more of this type of example. Thought we were done. Sorry. Is part E. And this time we're going to start off with x squared y to the 5 over the 4th root of 27 x to the 6 y to the 11. Alright, so this one we got lots of things going on. So again, the first thing I'm going to do is rewrite the number in terms of an exponent. So we have x squared y to the 5 over, this time it's the 4th root. 27 is the same thing as saying 3 to the power of 3, x to the power of 6, y to the 11. And again, before we move on, I'm going to simplify inside of the radicals first. So, numerator is staying the same, x squared y to the 5. Can't take out any 3's, but how many groups of 4 can I take out if I have an x to the 6? I can take out one of them, and I'm left with x squared. If I have y to the 11, how many groups of 4 can I take out? I can take out 2 groups of 4, because that's 8, and I'm left with y to the power of 3. And then again, right before I go to multiply by the top and the bottom by a radical, I'm going to simplify this up a little bit more. X squared over x is x in the numerator. Y to the 5 over y squared. Remember, dividing exponents, you subtract them. So y to the power of 3 over the 4th root of 3 squared x squared y to the power of 3. All right, now that we've totally cleaned it up a little bit, now let's multiply the top and the bottom by the 4th root. I have 3 2's, so how many more 3's do I need in order to make a group of 4? I need 2 more. How many more x's do I need to make a group of 4? 2 more. And how many more y's do I need to make a group of 4? This time you only need 1. So again, the numerator, x, y cubed, the 4th root of 3 squared x squared y over 3xy. And notice every time you do it, whatever the base is of the exponent of the denominator is always what you're left over with. But again, this x and this x cancel. So our final answer is y. And then we had 3 y's, we had this one, so now we have 2 of them. 4th root of 3 squared x squared y all over this x canceled, that y canceled, 3. All right, and our very last type is called multiplying by the conjugate. I think we've done this already this year, but I'm just going to refresh our memory. Remember, if we have a plus b, then the conjugate would be a minus b. Okay, if we have x minus 4, the conjugate is going to be x plus 4. Remember, all you're changing is the sign. If they give you the minus, it becomes the plus. They give you the plus, it becomes the minus. And another thing that we're going to have to remember to do here is FOIL. FOIL is going to be your best friend in order to do these types of examples. We only have 3 examples, and then we're done for today. So our first one, A, we start off with 8 divided by the square root of 11 minus 3. Again, this one, in proper math grammar, you cannot leave a square root in the denominator, but this time in our examples, we have 2 terms in the denominator rather than just the 1. So in order to do that, the denominator is the square root of 11 minus 3. So in order to get rid of this, we have to multiply by the conjugate, which is the square root of 11 plus 3. Again, you have to do it to the numerator and the denominator because technically you're not changing the value, you're only changing the way that the expression looks. So again, I'm going to do the distributive property here. We have 8 square roots of 11. 8 times 3 is 24. Over FOIL on the denominator. Square root of 11 times the square root of 11 is the square root of 121, which is just 11. The outer term, square root of 11 times 3 is plus 3 square roots of 11. The inner terms, minus 3 square roots of 11. And our last terms, minus 9. And the cool thing about when you multiply by the conjugate, you will always, always, always cancel out your outer and your inner terms. If you're doing it correctly, your outer and your inner terms will always cancel. Our numerator is 8 square roots of 11 plus 24 over, we're left with 11 minus 9, which is 2. When you have one term in the denominator, you can do, remember I call it the little heart trick? And create a little heart so you can separate it. You can have 8 square roots of 11 over 2 plus 24 over 2. So your final answer, 4 square roots of 11 plus 12. Cool. So again, knowing what the conjugate is and being able to FOIL, 2 best friends in this case. Another example, part B, we have 2 over the square root of 3, this time plus 5. So this case, we're plusing or adding, so our conjugate is going to be the square root of 3 minus 5. Again, distributive property and FOIL. 2 square roots of 3 minus 10. Just taking this 2 and multiplying it to both of those terms. First term, square root of 3 times the square root of 3 is 3. Outer terms, 5 square roots of 3. Plus 5 square roots of 3, minus 5 square roots of 3, plus 5 square roots of 3, and then 5 times negative 5, minus 25. So you're going to be left with 2 square roots of 3 minus 10. Noticing again the outer and the inner terms cancel. Negative 22 in the denominator. And again, we can do our little heart trick. 2 over negative 22 is negative square root of 3 over 11, or the negative 1/11. Negative 10 divided by negative 22 is a positive 5 over 11. There you go. So sometimes you're left with fractions. Fractions are fine as long as the square root is not in the denominator. Denominator. Blah, blah, blah. All right, and our last example for this morning's work, part C. Got to throw in some variables in there. So 9 divided by the square root of 3y minus 6. Again, the conjugate is going to be the square root of 3y plus 6. Doing the distributive property, 9 square roots of 3y plus 54 over, FOILing in the denominator, square root of 3y times the square root of 3y is 3y. Our outer terms, plus 6 square roots of 3y. Inner terms, minus 6 square roots of 3y. Negative 6 times positive 6, minus 36. Again, outer terms and inner terms cancel. You're left with 9 square roots of 3y plus 54 over 3y minus 36. Now that would be a totally acceptable answer, and that's a good answer. An even better answer would be to factor out a 3 out of both of these terms, the 9 and the 54. So you have 3 square roots of 3y plus 18 over factoring a 3 out of both of the terms in the denominator, y minus 12. These 3 cancel. So your final perfect answer would be 3 square roots of 3y plus 18 over y minus 12. Again, this is the best answer. This is an okay answer and will be fine for now. Awesome job, guys. You survived day number 2.